So we have some examples of simplifying here. We have the square root of 5 squared. So you know that the square root and the square eliminate themselves. Your final answer is just 5. What's the square root of negative 1? What's the answer there? It's just I, right? So the answer is I on number 2. How about number 3? What's the square root of negative 1 times the square root of negative 1? That kind of undoes itself. The square root and the square undo themselves, so your answer is just negative 1. What is the square root of negative 64? Think about this. We're going to rewrite the square root of negative 64 as negative 1 times 64. Now, why would I do that? So I could split it and say negative 1 times 64, but with the square root on each of them. Now, what's the square root of negative 1? I. And what's the square root of 64? 8. So you really have I times 8. So the answer to number 4 is 8I. Now, you're thinking, wait a minute, I times 8, how do I do that? I is like just a variable. What's x times 8? It's just 8x. So I times 8 is just 8I. Okay? Moving on down here. Let's solve one of these guys. Number 1. Let's say I wanted to solve that. I want to get rid of the square. I'd have to apply a square root and apply a square root. I'm going to have x equals, I will have a plus or minus right in front of my answer. However, I need to rewrite this. I want to rewrite it as a negative 1 times 75. That way I could split it and have x equals plus or minus. I want to split the negative 1 and the 75. And we know that the square root of negative 1 is what? I. And we need to multiply that by the square root of 75. But the square root of 75 is really 25. Whoa, that's not a 25. (25) times 3. So what do I really have? I really have 5 times the square root of 3 times I in the front with a plus minus right in front. So out of all these things, I could at least rearrange it. And I would say the best answer, the best looking answer would be x equals plus or minus 5I, kind of like if it were 5x, and then a square root of 3 at the very end. Now, sometimes I've seen the I being placed out here at the end, outside the square root. That's fine also, but there's my answer. By the way, remember I said finding the answers is the same thing as finding the x-intercepts, finding the solutions. It's also the same thing as finding the roots. Why is it called finding the roots? Because when you find the answers, what are we applying here? We're applying a square root. So that's why the answers are also called roots. So for the sake of time, let's skip over to complex numbers. A complex number written in standard form is a number a plus bi. The a part is the real number. The b is the imaginary part. The bi is the imaginary part. So let me repeat that. A complex number has 2 parts. It has the real part that's always first and the imaginary part that's always second. It's written as a binomial. Okay? Let's continue reading here. Operations with complex numbers is the same as variable expressions. However, if you end up with an I squared, you must replace it with negative 1. That's the only catch. That's the only detail. So when I look at number 1 right here, and everybody should follow along here, if I pretend that that's a 3x times 2x, my answer would be 6x squared. In this case, it would be 6I squared. However, we know that I squared is really negative 1, so my final answer is going to be what? Negative 6, because I really have 6 times negative 1. So my final answer is negative 6. Cool? Moving on to number 2. This is addition. I'm not going to end up with an I squared. I just treat it like an x, right? 3x plus 2x is 5x. In this case, 3i plus 2i is 5i. Done. This is what we call an imaginary number, but it's also called a complex number. It's just missing the real part. If you actually wanted to write the complete complex number, you would say 0 plus 5i. If you wanted the complete complex number. So you could have a real part showing that, you don't have to, but this is showing that your real part is 0 and your imaginary part is 5i. A complex number has two parts. So how do you distribute? Just the same way as we did before with variables. 3 times 4 is 12. 3 times 2i is 6i. And that's it. There's your answer, 12 plus 6i. That's it. And believe it or not, we are going to have these types of questions on the test Friday. Super easy. It's like 3 points right there. Distributing with i's, it's like x's. Number 4, let's distribute. You're going to distribute this whole term. Pretend it's like a negative 3x. Let's go negative 3x times negative 5. That's going to be a positive 15x. But in this case, 15i. Everybody knows that. How about negative 3i times a positive 2i? Well, that's going to be, what's a negative 3 times a positive 2? Negative 6. And how about I times I? That's I squared. Now, I already know that you guys know that I squared is negative 1. I'm just going to write it there just for a little while so everyone could clearly see that this right here is really what? What's really a I squared? Negative 1. So let me show my work here so everybody understands. 15i minus 6 times, we said this was negative 1 because I squared is negative 1. So I really have a 15i plus 6. Now, this is the correct answer. However, it's not in the correct form. How do complex numbers look like? You have your real part first and your imaginary part second. So your final answer should be the real part first, 6 plus 15i. Let's try number 5. Right here, we're just going to distribute the minus sign, change the sign, change the sign. So you're really going to have 4 plus 2i minus 3 minus 5i. It's just a question of combining like terms. Now we know that complex numbers have the real part first. So let's start with the real number 4 and the real number negative 3. That's really a real number 1. Now let's go for the imaginaries. A positive 2i and a negative 5i. It's going to be a negative 3i. Not a negative 3i squared. We're not multiplying. We're just combining the terms. This is your answer. That's your complex number 1 minus 3i. Let's check out the next one. This is where it gets more fun. All right, we're going to distribute. Let's go 1 times 3. That is 3. Let's go 1 times 4i. That is a positive 4i. Let's go positive 2i times 3. That's positive 6i. Let's go positive 2i times positive 4i. That's positive 8i times I is I squared. Now, again, it's done all exactly the same as if it were an x. But we have i's here. The only difference is that if you end up with an I squared, we need to replace that I squared with a negative 1. So let me rewrite this. So far I have a 3 in the front. I have a positive. If I combine the 4i with the 6i, that's going to be a positive 10i. And let's go to the plus 8. But that 8 does not have an I squared anymore. It really has times negative 1 right there because I squared is really negative 1. So what do I really have? I have a negative 8. So instead of 8 times negative 1, you could think of it as negative 8. And now let's combine like terms and write it as in the form that we're supposed to with the real part first. So when I say what's 3 and negative 8, that's negative 5 as my real part of my complex number. And then plus 10i, which is the imaginary part of my complex number. And there's my answer, negative 5 plus 10i. Now let's get to something really awesome. I think it's awesome. These binomials almost look the same, don't they? The only difference is that one has a plus, one has a minus. So let's watch the magic that happens here. 3 times 3 is 9. 3 times negative 2i is negative 6i. And then positive 2 times 3, that's positive 6i. And then positive 2i times negative 2i is negative 4 with an I squared. Now I'm saying watch the magic happen because the middle terms, one's positive, one's negative, they completely cancel out. No more i's in the middle. And then when you look at that last term, you have a negative 4 times I squared. That's really a negative 1. So that's really a negative 4 times a negative 1. What's that going to be? Positive 4, right? So you really have this 9 plus 4. It's really 9 plus 4. So the final answer is 13. 13. So all the imaginaries canceled out, and we'll pick up there tomorrow.